Today I'm going to look inside of another version of the Utilitech LED light bulb. This version is an 800 lumens, 60 watt incandescent equivalent LED bulb that it uses 8 watts to output 800 lumens. And according to the box, it is supposed to last 10,000 hours instead of the 5,000 hours the other Utilitech bulbs were rated to last. Now because this bulb is brand new, when I turn on the switch, it works. But although it works, I'm going to take a look inside of it to see how they've designed this bulb. And of course with these LED bulbs, they are glued together, so we use the hot air to open it. Alright, heat it up a bit. And oh, that's interesting. More heat, maybe? Oh, this is different. I can already see in it a little bit. Ooh. Oh, I can see a control chip on the board. Ooh. Ooh. Well, this is different. There's a control chip on the board, 8 LEDs, and a small resistor here, and 2 little connectors. And something interesting is they're using a wavy track as a fuse here. So the structure of this LED bulb is quite different than the last one. There's some large chip on this circuit board, and it uses 8 LEDs instead of 9 LEDs. And also, it has a metal heatsink to help dissipate the heat of the LEDs into the case, which is much better than the last one. But now I'll try and remove all this plastic to see what's under the LED board. Ooh, it's going to be underneath the control board. Oh, that's interesting. There's a capacitor, a 105 degrees Celsius electrolytic capacitor, connected using a push-in connector to this board. And also, there's a resistor and wire connecting the contacts of the lamp socket through another push-in connector to the circuit board. There's no other driver circuit like the last one. The driver's on this top LED plate, which is pretty interesting, and the connector wires just came out. So this is the front side of the circuit board, and this is the back side of the circuit board. And the capacitor is rated for 15 microfarads, 200 volts. Well, this LED board is quite interesting, and they designed it in a very, very clever way. So first, the mains comes in through the 10 ohm resistor, which is this one, and through a fuse, which is the wavy track on the board. Then it connects to one pin of the controller chip. The neutral wire also connects to another pin of the control chip. Then, this pin of the control chip connects to the positive terminal of the 12 microfarad 200 volt capacitor, which also has a 510 kilo ohm resistor in parallel with it to discharge it when you turn off the lamp, and to prevent the lamp from glowing dimly when the switch is off. The negative pin of the capacitor also connects to this pin of the control chip. There's also a 12 ohm resistor connecting from the negative terminal of the capacitor to this pin of the control chip. And this last pin of the control chip connects to the negative wires of the LEDs. The positive terminal of the capacitor also connects to the positive of all the LEDs. What's interesting is there are 8 LED chips, all in series, and each chip contains 5 diodes per chip all in series. So in total, there are 40 LEDs in series on this board. What's interesting is that the negative line of the LEDs appears to go through this chip's internal current limiting system through a 12 ohm resistor and then to the negative line here. This 12 ohm resistor could help the chip sense the current. I find it quite impressive that all of the current regulation stuff is happening inside of this small chip. Now, I could not find a datasheet for this chip, although I found a datasheet for something similar to it, and it is a linear LED current regulator, which explains that there's no inductor anywhere here. So, it actually is possible to modify this specific lamp to make it lower power and last much longer. All I would need to do is remove this resistor on the board and replace it with a higher value resistor to make the chip think that there's more current flowing through the LEDs, when there actually is less. In a future video, I might test this idea. I also find it interesting how they're using these connectors to connect the capacitor to the board and also connect the AC mains wires to the board. So in conclusion, this LED bulb is a lot better than the previous Utilitech LED bulb that I've taken a look at in 2 of my videos. The one that has the 5,000 hour lifespan and the LED and driver board separate. It's much better because they have now put a piece of metal inside of the LED lamp housing to help the LED board dissipate the heat, which probably is what gives it the 10,000 hour lifespan. And if this chip has a built-in overheating protection method, then it will more accurately sense the temperature because it's on the same board with all of the LEDs. Also, this chip's heat is going to get dissipated into the metal back circuit board, which could help it last longer. Anyways, make sure to subscribe for more videos.